Hey, welcome to the second episode in this series, Unlocking Industrial Automation with Open Source Tools. In the first episode, I introduced a pressing issue many engineering graduates face, the disconnect between classroom theory and industrial practice. Today, I want to dive deeper and show how you can start bridging that gap practically, using powerful tools that are completely free and open source. Now, here's the exciting part. You don't need to invest in expensive hardware or proprietary software to begin developing real-world automation skills. There are several open source platforms out there that can help you simulate, test, and even deploy industrial automation systems, and the value they offer is immense. These platforms are reshaping how control engineering is learned and practiced outside of traditional environments. Take OpenPLC, for example. It's one of the most robust open source industrial automation environments available today. Built to comply with the IEC 611313 standard, it allows you to write programs using ladder logic, structured text, function block diagrams, and more. Exactly the same standards used by top-tier platforms like Siemens TIA Portal or Allen Bradley's RS Logix, but that's just one piece of the puzzle. Beyond OpenPLC, you have platforms like Node-RED, which offers visual programming for IIoT and edge integration, Grafana and InfluxDB, which allow you to log, visualize, and analyze process data, MQTT brokers like Mosquito for lightweight messaging in distributed control systems, and CodeSys, another industry-recognized environment that has a generous non-commercial license. There's also Factory.io, a 3D simulation tool where you can build and test PLC logic in realistic virtual industrial environments. Even SCADA BR, MySCADA, and Ignition SCADA offer community or trial versions that are useful for building real-world control dashboards. So, with a laptop and internet connection, you have access to a full industrial stack from sensor simulation to control logic, data logging, and human-machine interfaces. These tools not only simulate industrial processes but also support protocols like Modbus, OPC UA, and Ethernet IP, making them suitable for professional-grade integration projects. Now let's bring the spotlight back to OpenPLC, which will be our working platform for the next few episodes. OpenPLC allows you to develop ladder logic programs, simulate them without any physical device, and later deploy them to real hardware like a Raspberry Pi or Arduino. OpenPLC supports I/O simulation, tag mapping, Modbus communications, and seamless integration with other systems like Node-RED or SCADA interfaces. For beginners and professionals alike, OpenPLC is a brilliant way to visualize, test, and understand automation logic. Getting started is straightforward. First, go to www.openplcproject.com, navigate to the Downloads section, and select the version of the OpenPLC editor that matches your operating system, whether you're on Windows, Mac, or Linux. Once installed, you'll have a development environment that allows you to write logic using any of the IEC languages, though we will focus on ladder logic for now. Next, for those who want to simulate their projects without hardware, the editor includes a built-in simulator. If you're interested in testing your logic on real devices, you can also download the OpenPLC runtime and install it on supported hardware like a Raspberry Pi, Arduino, or even a soft PLC environment on your PC. This runtime allows you to deploy your control logic to physical I/O devices, enabling real-world interaction from motor control to sensor feedback. In the next episode, we'll begin writing our first logic project, a motor start-stop sequence with safety interlocks, built using ladder logic in OpenPLC. This will be our foundational hands-on experience. We'll break down how to structure your PLC logic, simulate it using the editor, and prepare it for deployment to a runtime environment. Remember, this isn't just about learning syntax. This is about understanding how real industrial systems behave, how they are structured, and how to build the logic that drives them. With open source tools, you don't have to wait until you get hired into a factory or a plant. You can start training yourself now from anywhere. So, like, share, and follow for the next video. If you're serious about mastering control systems, this series will empower you to build real-world skills using accessible, professional-grade tools. The journey from theory to industrial reality continues, and this time we're building logic that speaks the language of the future. This is where theory meets reality and your journey into practical automation begins. Watch, learn, and build.